Hello, Matthews, Gatos here. Welcome to section 2.2, part 1. Before I get into this, I just want to review 2.1 first. So I want to fill in this table using our special triangles 30, 60, 90, and 45, 45, 90. Now, when I say exact values, that means no decimals. So you have to leave it as fractions or you have to leave it as roots. So let's just review again the two special triangles. So 30, 60, 90. So here's how I remember this. 30, 60, 90 is 1, 2, 3. Well, not just 3, root 3. So the first thing that I know is that 30 degrees and root 3, they're always going to be side by side. Okay, then I know the other sides are 1 and 2. 2 has to be the hypotenuse because it's the biggest number. Okay, so remember 30, 60, 90 is 1, 2, root 3. Always put the root 3 along the 30 degrees, and then the other sides are 1 and 2. 45, 45, 90, that is an isosceles triangle because 45, they both have 45-degree angles, and when your base angles are the same, you know that your triangle is isosceles. So 45, 45, 90 is just 1, 1, root 2. So because it is an isosceles triangle, the 45 and the 1 go side by side because they're isosceles, 1 and 1. And then 1 and 1, 2, but it's square root 2 because a squared plus b squared equals c squared, and then you have to take your square root. So 30, 60, 90 again, 1, 2, root 3. Root 3 and the 30 go side by side. 45, 45, 90 is 1, 1, root 2. The 1's go together because it's an isosceles, and then root 2 is the hypotenuse. Once you have those memorized, then you can do the exact values of everything. Okay, so if I look at the exact value of, let's do 30 degrees. So for the base angle for 30 degrees, sine is opposite over hypotenuse, 1/2. Cosine is adjacent over hypotenuse, root 3 over 2. Tangent is opposite over adjacent, 1 over root 3, but we need to rationalize that by multiplying top and bottom by root 3. Okay, in this same triangle, we can now do 60 degrees. So 60 for sine is opposite over hypotenuse. So when I change the reference angle, I change what is the opposite and the adjacent. But notice the hypotenuse always stays the same. Okay, let's look at cosine. Cosine is adjacent beside over hypotenuse. And then tangent is opposite over adjacent. So root 3 over 1, which is just root 3. Now let's move to the 45, 45, 90 triangle right here. So sine, and it doesn't really matter which 45 you use. If I use this 45, it's opposite over hypotenuse. If I use this 45, it's opposite over hypotenuse. It's the same thing. 1 over root 2, which I put into lowest terms by rationalizing my denominator. So it was 1 over root 2, but then I multiplied top and bottom by root 2. And that's how I get root 2 over 2. So we always want to rationalize our denominator. Okay, cosine is the same thing. Adjacent over hypotenuse, or if I use this one, adjacent over hypotenuse. So again, it does not matter which one you use. You're going to get the same answer. There we go. And again, rationalized. And then 45 for tan, opposite over adjacent, 1 over 1. Or if I use this one, 1 over 1, you still just get 1. Okay, so opposite over adjacent is just 1. So we'll just scratch that off. It should just be just 1 over 1, which is just 1. Okay, so that's a review of your special triangles. So in this lesson here, what we're going to do is we're going to determine the value of sine, cosine, or tangent of any point on the terminal arm of an angle. We're also going to look at what happens in the second half with these quadrantal angles and how do we solve for all values of theta in an equation that involves sine, cosine, and tangent. So let's get started. So first thing we're going to do is find the ratio given an angle using special triangles, or for those of you that like the hand trick, you guys can use the hand trick as well. So the reference angle when it's 30, 45, or 90 using the triangles or the hand trick can help you find the exact value of all your trig ratios, sine, cosine, tangent. So for any question that we do, I really recommend that you sketch the angle, find the reference angle, and then label all the sides of the triangle in that quadrant. That's super important because sometimes x and y are going to be negative. but our hypotenuse will always be positive. And then you're just going to find the trig ratio using that triangle. Okay, so I really want you to pay attention to the signs. Okay, so the signs in all the quadrants. So quadrant 1 is positive, positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both x and y are negative. And in quadrant 4, x is positive, y is negative. But remember, the hypotenuse is always going to be positive because the hypotenuse is the length of the segment from the point to the origin, and length is always positive. Okay, let's share some examples. So you can see I have my special triangles on the side here. If you prefer to use your hand trick, totally fine. Okay, so I want to find the exact value of tan of 150. So I have my little protractor here and I'm going to sketch 150. I like to draw it to scale just so you can better see it. So there's 150 degrees. Now, what I really want to do is I don't want to work with 150 degrees. I want to find what the reference angle is. So the reference angle is how the distance between this arm and the x-axis. So you can see it's 10, 20, 30, or you can actually calculate it by doing 180 minus 150. Okay, so let me just put this angle in there. There we go. Oh, let's get this guy out of there. There we are. Okay, so here's what my angle is. This is my 150 degree angle, but I'm not working with 150 degrees. I'm going to work with a 30 degree reference angle in quadrant number 2. So what I'm going to do is drop my perpendicular line down like that, and I'm going to label my triangle. Okay, so if you look at this 30 degree angle here, reference angle in quadrant number 2. So I can actually just even take, wow, that was interesting. I can go and take this triangle and actually put it right in there and sketch what the side lengths are. So you can see what it is if I place it in there. A little bit sloppy, but let's just put it over to the side here. So I know that it's going to be root 3, because remember 30 and root 3 are always side by side, 1 and 2. But I need to place this in the quadrant. It's in quadrant number 2. And in quadrant number 2, x is negative, y is positive, hypotenuse always positive. Okay, so now I want to find tan of 150. So as I said before, tan of 150 is going to be the same as tan of 30 degrees in quadrant number 2. So tan of 150 is the same as tan of 30 degrees in quadrant 2. So I know that tan of 150 is going to equal to opposite over adjacent, negative root 3. Now let's just rationalize that denominator. Root 3 times root 3. So that's really going to be 1 times root 3 is root 3. Root 3 times root 3 is 3. And let's put the negative in the numerator. We don't want to lose it, so common convention, a negative in the denominator comes up to the numerator. So this is what tan of 150 degrees is. Okay, so you can check all of these things on your calculator. So let's look at a check here. Tan of 150 is this answer here, and negative root 3 over 3 is the same value there. So you know that you are correct. Really important that your degree, your mode is in degree. Remember, when you reset your calculator, it's going to default to radians, but we are always working in degrees. Okay, let's try another one. I want to find the exact value of sine of 140, so I need to make this bigger. There we go. So let's first of all sketch what a 240 degree angle equals. So there's 240 degrees right there. So to figure out my reference angle, I've gone past 180, so I'm just going to go 240, take away 180, and you can see here 10, 20, 30, 40, 50, 60, or algebraically you can see that your reference angle is 60 degrees. Okay, so let me just insert that in there and get rid of that guy. And there we go. So instead of working with 240 degrees, I am going to work with my reference angle of 60 degrees. And that reference angle of 60 degrees in quadrant number 3 is what I'm going to work with. So instead of working with 240 degrees, I am going to work with 60 degrees in quadrant number 3. So sine of 240 is the same as sine of 60 degrees in quadrant number 3. So let's draw our triangle with the perpendicular line segment. Let me make sure of that again. Perpendicular line segment like this. Okay, so I know this is a 30, 60, 90 triangle. So I have it on the side there. You guys can see it, but let's just label it. So remember 30, 60, 90 is 1, 2, root 3. 1, 2, root 3. The root 3 and the 30 always go side by side. So that means I know that my root 3 is here. So it's going to be 1, 2, hypotenuse is always 2, root 3. Now let's label it in quadrant 3. In quadrant 3, x is negative, y is negative. Hypotenuse, always positive. Okay, so as I said, sine of 240, which I want, is the same as sine of 60 degrees in quadrant 3. So now that I've labeled it, let's calculate it. So sine of 240 is equal to sine of 60. So sine of 60, again, is opposite over hypotenuse. So opposite over hypotenuse. Nothing to rationalize or simplify, so that should be my final answer. But again, the calculator, that's our best friend in trig. We can check to see if we're right. So sine of 240 is this ugly answer here. And let's just check. We had negative root 3 over 2, and that's the same. So since they match, I know that this is correct. But again, I just want to reiterate, if I ask for the exact value, because I did, exact value means no decimal. So I want to see this as my answer. So if you guys were to state it as a decimal, that's not an exact value. Okay, let's try another one. So in this example, I'm looking for the cosine of 315. So I need to make that bigger. So cosine of 315. So let's go all the way around to 315 degrees, which is right there. So I am looking at cos of 315, which is a quadrant 4 angle. So I need to find the reference angle. So I haven't made it to 360 yet. So I can do 360, take away 315, and I get my reference angle of 45, which I can see is right because let's count here. 10, 20, 30, 40, 5 more. So I know that that's right. So let's get that guy. Oh, I forgot to insert the angle first. There we are. Okay, so let's work with this angle here. So this is a reference angle of 45 degrees. So let's drop a perpendicular line down and look at the triangle. So it's not perfect, but you get the point. So 45, 45, 90, I have that here. 45, 45, 90 is 1, 1, root 2. So let's go up here and label that. So we've got 1, 1, root 2. But I need to label it in this quadrant. So in quadrant number 4, x is positive, y is negative, hypotenuse always positive. So instead of working with 315 degrees, I am going to work with 45 degrees in quadrant number 4. Okay, so cosine of 315 degrees is the same as cosine of 45 degrees in quadrant 4. So let's write that out. So cosine of 315 degrees is equal to cosine of 45 in quadrant 4. So looking at my 45 degree reference angle, and I'm looking at this one here because it's always the reference angle with the x-axis. Okay, so I'm going to have adjacent over hypotenuse. But I need to rationalize my denominator. So multiply top and bottom by root 2. So then I'll have cosine of 315 degrees is equal to root 2 over root 2 times root 2. Root of the same thing times root of the same thing is the same thing without the root. Or you could say root 2 times root 2 is root 4, and the root of 4 is 2. So this is what the cosine of 315 degrees should be. Exact value, root 2 over 2. But again, we can turn to our calculator to check to see if we've done that correctly. So cos of 315 is about 0.7. Root 2 over 2, also 0.7. You can see that they're equal, so I know that I've done that correctly. So definitely take advantage of checking on your calculator. Okay, I just want to kind of reiterate what we've done so far, and we're going to look at all of the sides of the special triangles. Okay, so if I place a triangle and I just kind of separated it away from the x-axis so we can label all the sides. So let's imagine any kind of a triangle in general that I could place in quadrant 1, 2, 3, or 4. So hypotenuse, notice, is positive in every quadrant. Now in quadrant number 1, my x values along the x-axis are positive, my y values are also positive. So since all of the sides are positive, that means all of my trig ratios are positive. Okay, I'm going to go somewhere with this, I promise. Okay, if I look along in quadrant 2, looking at this triangle here, along the x here in quadrant number 2, that's negative. Along the y, the height along the y is positive, because in quadrant number 2, x is negative, y is positive. So looking at this side here with adjacent is negative. So any trig ratio involving an adjacent would be negative. So let's look at our SOHCAHTOA. So anything involving an adjacent is going to be negative. Well, what has an adjacent? Cosine has an adjacent. Tan has an adjacent. So it looks like cosine and tan will be negative, but sine, using opposite and hypotenuse, will be positive. Okay, so sine is positive, cos is positive, tan is negative. Okay, let's go down to quadrant number 3. So in quadrant number 3, along the x-axis here, I have x values that are negative, and down here, y values that are also negative, because in quadrant number 3, x and y are negative. So looking at this here, if you look at what I have an adjacent and an opposite that are negative. So let's look at our SOHCAHTOA. So anything involving an adjacent and an opposite should be negative. So look at sine. Sine is opposite over adjacent. Negative over positive is negative. Cosine has an adjacent. Negative over positive is negative. Now tangent, however, uses both of them. And a negative over a negative is actually positive. So it looks like sine and cosine are negative, but tangent will be positive. And let's move to our last quadrant here. In quadrant number 4, I know that my x values are positive and my y values are negative. So if we look at this, anything involving an opposite is going to be negative. So let's look at our SOHCAHTOA. Anything involving opposite will be negative. So sine will be negative and tangent will be negative. Cosine will be positive because that's adjacent, which is positive, over hypotenuse, which is positive. So in this quadrant here, sine is negative, cos is positive, tan is negative. Okay, well, where on earth am I going with this? You can notice something here. So if you notice, aside from quadrant 1 where everything is positive, look here. In quadrant number 2, only one thing is positive. Cosine and tangent are both negative. In this quadrant, only one thing is positive, tangent. In this quadrant, only one thing is positive, cosine. So notice, aside from quadrant number 1, only one thing is positive. And look, they're polite. They take turns, sine, tangent, and cosine. And then if sine is positive, the other two guys are negative. Look at tangent is positive, the other two guys are negative. Cosine is positive, the other two guys are negative. So let's kind of put this together. This all together is called the cast rule. So cast rule using the letters C, A, S, T. Okay, so cast rule, I just use the first letter to help me. So let's start with the C, because this is where it starts. This is where it starts, is at C for cast. Okay, so C stands for cosine. Only cosine is positive in quadrant 4. Then I go here, A. A stands for all. All of the ratios are positive. So I'm going in this direction here, like that. Okay, so S here stands for sine. Only sine is positive. And T stands for tangent. Only tangent is positive. So this is something that's going to help us when we're doing trig ratios in any of the quadrants. We can know now, before even calculating anything, whether it will be positive or negative for sine, cosine, or tangent in that particular quadrant. So let's look at and fill this in all together. So here's my little cast rule. So let's look at quadrant 1. So quadrant 1 stands for A, and that is all are positive. So sine, cosine, tangent, all positive. Let's move to quadrant 2. Quadrant 2 has an S, and S stands for sine. So that means that sine is positive, the other two guys are negative. Moving to quadrant 3, the T here tells me that T stands for tangent. Tangent is the one that's positive, which means the other two are negative. Quadrant number 4, we end up with C, and C stands for cosine. So cosine is positive, the other two are negative. So that's kind of a summary of the CAST rule. What I want you to notice is that each ratio is positive in 2 quadrants and negative in 2 quadrants. Let's look at sine. Sine is positive in quadrants 1 and 2, but negative in quadrant 3 and 4. Cosine is positive in quadrant 1 and 4, but negative in 2 and 3. Tangent is positive in 1 and 3, but negative in 2 and 4. This is important because when I'm given a ratio, I now know there are 2 possible answers for the angle. So we have to pay attention to that. Okay, so what we're going to do is look at finding an angle given a ratio using our special triangles. So first thing, when the ratio, that's not the angle, that's the ratio, that's the fraction. When it's given to you, identify the reference angle. So remember, we're dealing with 1, 2, and root 3, or 1, 1, and root 2. So depending on what numbers I'm given, I know what triangle to look at. Am I looking at the 30, 60, 90 or the 45, 45, 90? So look at the sign of the ratio, placing the angle in the correct quadrant. So if the ratio is positive and I'm looking at sine, I know it's in quadrant 1 and 2. If the ratio is negative, for example, and I'm looking at tangent, I know it's in quadrants number 2 or 4. So there's always going to be 2 answers. Okay, and then you can always use the reference angle, state the angle in standard form, and check your answer on the calculator. The check is super important because in trig you can know if you're right or wrong before you finish the question. Okay, so we're going to put special triangles together with the CAST rule to find out the answer. Okay, let's try some examples. Let's look at the first one. So sine of the angle is -1 over root 2. So I see a root 2 there. So I know right away I am talking about the 45, 45, 90 triangle. So I know I'm talking about this triangle here. Okay. So I know that my reference angle is going to be a 45-degree angle. Okay. So that's step 1 of the puzzle. Okay. So I know my reference angle is 45 degrees, just looking at the ratio. Second thing I look at is sine is negative. So I want to place this reference angle in the correct quadrant. So let's look at our CAST rule. Sine is negative in quadrant number 2 and in quadrant number 4. Sorry, that's 3 and 4. Oh my goodness, I can't add, or I can't talk properly. Okay, so it's negative in quadrants number 3 and 4. So let's draw a little sketch. So here in quadrant number 3, 45-degree angle, what would the angle be? All the way to here. So all the way to there is 180 plus 45. So that's my first possible answer. 180 plus 45, 225. That's one possible angle. Let's come up with the other. So it could also be in quadrant number 4. So let's put a 45-degree angle there. So this angle could be all the way to there. Notice how I didn't get quite to 360. I'm a little short. So that's 360. Take away 45 would be 315 degrees. Oh, let me add my degrees there. So if I've done this correctly, what this tells me is that sine of 225 will equal to -1 over root 2. And sine of 315 will also equal to -1 over root 2. So my answer here are the angles, the 225 and the 315. Let's go to our calculator and see, am I correct on both of these? If I am, then I know I got the right answer. So checking on the calculator. So I had -1 over root 2, which is this mess of a number, irrational number. And then I did sine of 225 and sine of 315, and they are both equal to that. So all 3 numbers match, so I know I've done it correctly. Remember that you need to be in degree mode though, okay? So always check, make sure you're in degree mode. You're never going to need to be in radian mode in 20-1. Okay, So what happens if you can't use special triangles? Because not every ratio is going to be one of those nice guys. Okay, so what we're going to do is we're going to go to our calculator to do that. So if I can't use special triangles, now here's a hint. If I ask you to find the angle measure to the nearest tenth, or if I ask you to find the sine ratio to the nearest tenth, anytime you're told that you're going to be using decimals, that means it's not an exact value, which means it's not one of my special triangles, but I can still come up with it. So the only difference between special triangles and not special triangles is the reference angle. Everything else is the same. So if I have a special triangle, I can find the reference angle. It's going to be 30, 45, or 60. But if I don't have a special triangle, I have to go to my calculator. So the biggest thing that I can tell you about your calculator is when to use what button. So you have the buttons that are sine, cosine, and tangent. Those buttons are used when we have the angle, we're given the angle, we have it, and we want the ratio. So you want the ratio. Well, that's not what we're dealing with. We want the reference angle. So this is going to be when we're going to use sine inverse, cos inverse, or tan inverse when I'm given the ratio. In other words, I have the ratio and I want the angle. This is going to help us find our reference angle. Okay, so I'll do a couple examples showing you. Once you have the reference angle, it's the same thing as we did before. Okay, so here's what we're going to do. Find an angle given a ratio using sine inverse, cos inverse, or tan inverse. So first thing is we find the reference angle. So to find the reference angle on the calculator, we always want positive ratios. So I want you to use, now if the question gives you sine, then use sine inverse. If the question gives you cosine, use cosine inverse. If the question gives you tan, use tan inverse. So use sine inverse, cos inverse, or tan inverse with the positive ratio, even if it's negative. The negative sign helps us place it. So the negative sign helps us correctly place it in two quadrants. So step one, find the reference angle. Step two, place it in the quadrant. And then using your quadrant and your reference angle, state the angle in standard form. And always, always, always check your answer on the calculator. Okay, here we go. So determine the measure of angle theta to the nearest degree. So here, see, it's telling you around. That tells you, oh, I'm not using special triangles. Given that tan is negative 0.8090. Okay, so first thing first, I want to find where this angle is, and then I want to find the reference angle. So let's find the reference angle first. So ignoring the signs, I don't know what happened there. Let's try that again. Ignoring the signs, find the reference angle. So notice I had a negative here, but I didn't have a negative here. I enter it in as positive because I just want the reference angle. Okay, this negative is going to tell me where the angle goes. So tan inverse, I used tan inverse because I had tan. Tan inverse of 0.8090 is 38.97. Now they want it to the nearest degree. So that tells me my reference angle is 39 degrees. Okay, step one done. Step two, where is tan negative? Okay, so using the original ratio, which is that tan, where is tan negative? Well, let's use our cast rule. Tan is negative in quadrant number 2 and in quadrant number 4. So we're going to put these two things together. We're going to take the reference angle of 39, put it in quadrant 2, take the reference of 39, and put it in quadrant 4 to find out our final answer. Okay, so here we go. So 39-degree reference angle in quadrant 2 and in quadrant 4. So in quadrant 2, the angle is here, 180 degrees minus 39 degrees. Okay, so that's 141 degrees. So that's one possible answer. Okay. Another possible answer is in quadrant number 4. All the way around to there. I haven't made it to 360. I'm short 39 degrees. Okay, so I know subtracting those, that's going to be 321 degrees. So there are my two possible answers, 321 degrees or 141 degrees. Final step in any question that we do is the check. So let's see if I did that right. So 141 degrees works. 321 degrees also works. Both the numbers match, so I know that both of these guys here are correct. So you see, the only difference was we had to use our calculator to find our reference angle. Everything else was the same. Okay, I really love this joke. This is cute. So the triangle says to the other triangle, "Oh, hi, Pot and News. We didn't see you there. Hypotenuse, hypotenuse." I think that's pretty good. I'm high-fiving myself right now. Okay, so you guys can do practice questions 1 to 3 and